Hey class, I just wanted to finish going over the worksheet from class that we didn't get to finish. Let me start at number 3. We were able in both classes to finish 1 and 2. We were able to make some progress on 3, but I just wanted to walk through it again and actually do it in a couple different ways so you guys can see how things can work in different ways. You can do the way that you prefer. So we're going to find the equation of the line through the origin that intersects line K at right angles. So this is what I'm at right here. So that intersects line K at right angles and is perpendicular to line K. So we're going to go through the origin. We're going to come over here somewhere. So this intersection here is perpendicular. So the way in both classes that I talked about doing it was doing it with a projection. So if you think of projecting AB, this vector, onto this vector, oops, then it will result in the vector that goes up to this point, and so it's perpendicular where that blue vector intersects the green vector. So to do that, one of the nice things about using projections is we have an explicit formula for those. We just need to know what BA is and BE is. Looks like I cut off my E. E is right up there. So BA, let me get back into black. BA vector is a minus 2, 0, 0. We could do that by subtracting, taking 0, 0, 0 and subtracting 2, 0, 0, or we can see that we go a negative 2 in the x direction, and our y is unchanged and our z is unchanged. So BE, that will be, so we subtract the tail from the head, so E is a minus 1, oops, E is 1, 1, 2, subtract 2, 0, 0, we get a minus 1, 1, 2, and now we can apply the projection formula. So we're going to project B onto BE, and we're going to project BA onto BE, and the formula says, hey, take the dot product of those two things, and then the dot product of the vector with itself that we're projecting onto, and multiply all of that by the vector we're projecting onto. Because again, as I mentioned in class, the vector that we finish with is just a scaled version of BE. It's a scaled version of the vector we're projecting onto. So this here is, this expression just gives us a constant that will scale it the right way, the right length. And we know what BA and BE are, so we can plug those values in. And BA is a minus 2, 0, 0, dotted with BE, which is a minus 1, 1, 2, and a minus 1, 1, 2 dotted with itself. Oops, multiplied by a minus 1, 1, 2. So this is just a constant multiplied by this vector, and we end up with a dot product in the numerator. So that's going to be a minus 2 times a minus 1 plus 0 times 1 plus 0 times 2, and that whole thing equals 2. And then here we have a minus 1 in the denominator. You've got minus 1 times a minus 1, plus 1 times 1, plus 2 times 2. And that equals 1 plus 1 plus 4. So that whole thing is 6. And we multiply that by minus 1, 1, 2. And that ends up just being 1/3. Times minus 1, 1, 2. So a minus 1/3, 1/3, and 2/3. That is our vector. So this is the vector that goes from B. If we started at B, it would go up and end at that point. But to find our actual coordinate, we have to actually add it to point B, so we know that's the beginning point. So the point is 2, 0, 0 plus a minus 1/3, 1/3, 2/3. Because this vector represents a change. A lot of vectors represent a change in position, not the position itself. It only represents the position if it's at if it starts at the origin. So if we add B to this projection vector, then we should get the coordinate. So we end up with 5/3, 1/3, 2/3. And that makes sense because if we go 5/3 in the x direction, we get almost to B. Right, so we're going to be about here. And then we go 1/3 in the y direction, so we're going to go a little bit that way. And up 2/3. So up to there. So yeah, it's about right 0.666. So it makes sense with our drawing. So there's a point. And what about the line? Because up here it does ask, what is, we kind of did the second part first. What's the point of intersection? We found the point of intersection. Find the equation of the line through the origin that intersects line K. So, intersects line K at right angles. Well, here we have a point. We actually have 2 points, and we can use the 2 points to find a vector, and then use the vector equation for the line. So the equation of the line, vector equation is really easy to write, would be x vector equals a point. I'll just pick the origin, because the origin is on that line. Right, we're going from the origin over to there. And plus t, and the vector that goes from the origin to the coordinate 5/3, 1/3, 2/3 is just, the vector is just 5/3, 1/3, 2/3, because we're in standard position. So 5/3, 1/3, 2/3. So there's the equation of the line. And now we're done with 3. Now there's another way to do this, a couple other ways to do this.